Alright, so today we're going to look at secants, tangents, and angle measurements. This will, for the most part, we have one other section, but for the most part it'll finish off your Ames reference sheet. And you will have learned nearly everything on that sheet. The only other thing that we'll have to go over are area, volume, and perimeter formulas, and then that's it. We'll be ready for the Ames. Woohoo! But here we got a secant line. If you remember your definition or what a secant line is different from a tangent line because it's a line that intersects the circle in exactly 2 points. It contains a chord of the circle. So for instance, if you look at this picture down here, AC is a chord, ray CA is a secant to the circle. It's part of a line. And since it's only going in one direction, it is a ray. Whereas line TC is tangent to the circle. Assume that that hit it exactly. And then what would AB, ray AB, be? AB is a diameter, but what's ray AB? That's a secant. So a secant, remember a chord can be the diameter. So, and a chord is, and a secant is different from a tangent in the sense that it intersects the circle in 2 places. The tangent intersects it in only 1 place. So theorem 911 says, if a secant and a tangent intersect, so here's a secant and here's a tangent intersecting here. At the point of tangency, so this is the point of tangency right there, where they're intersecting. And that's the key to this particular theorem. Then the measure of each angle formed is 1/2 the measure of its intercepted arc. So here's a different type of angle. We've had a central angle where the vertex is at the center of the circle, and the measure of the intercepted arc was exactly the same as the measure of the central angle. Then we've had an inscribed angle where the vertex of that angle was on the circle, and I'll grant you the vertex of this angle here, and we're talking about the angle from here to here, is on the circle, but the sides of the angle do not contain 2 chords of the circle. So remember that an inscribed angle, part of its definition was that the sides of the angle included 2 chords. This includes 1 chord and not a chord at all. It's a tangent line. So that means, and technically it's not an inscribed angle. But do you notice that its measure for this one is exactly the same as an inscribed angle was? 1/2 the measure of the intercepted arc. So still, we only have 2 different types of angle measures, same angle or half of the intercepted arc. So if you look at this, angle TCA is equal to half of the arc AC. Segment or ray CA is a secant, so add that in here. And we noted that line TC was a tangent. And we noted that ray AB was also a secant. Now, having said that, this angle here that's formed by the 2 secants, isn't that an inscribed angle? The intercepted arc of CB would be exactly half of the intercepted arc still. There's an angle here also formed at AC, whatever this point would be. This angle here, this is the intercepted arc to that angle. That would be, this angle here would be half of this intercepted arc. So you can end up with 2 different angles when you have a tangent and a secant. Alright, so let's look at example 1. You were told that KD is tangent to circle C at point D, so point D is the point of tangency. I would immediately put a right angle there. Because DC is part of a radius, well, it's part of a diameter radius that's hitting a point of tangency. Prior knowledge tells us that that's a right angle. Find the measure of angle KDE, KD to E. We already know it's right from a previous one, but look at the intercepted arc. From K to D to E, this is the intercepted arc. What part of the circle is that? Semicircle, which is 180 degrees. So wouldn't it make sense that that would still be 90 degrees because half of 180 degrees, the measure of angle KDE is equal to 1/2 of the measure of arc DAE. which is equal to half of 180, which is equal to 90 degrees. So now we have two different theorems that will get us to the same place. Then at the very bottom of this page is theorem 912. If two secants intersect in the interior of a circle, then the measure of an angle formed is 1/2 the sum of the measures of its arcs intercepted by the angle and its vertical angle. So we're going to draw a picture. So if two secants intersect in the interior of the circle, the measure of an angle formed is 1/2 the sum of the measure of its arcs intercepted by the angle and its vertical angle. So what does that look like? Do you have room on the back? Nope. So let's draw a little picture right here. So draw yourself a little circle. And then I want you to draw two straight lines not intersecting at the center of the circle. So I don't want them intersecting at the center. And we're going to call the following points. This point here is S as in Sam. This is T as in Tom. U as in under. And R as in Roger. And then this is angle 1 right here. And 2, 3, and 4. All this is saying is, suppose that I was looking at the measure of angle 1, right there. I wanted to find the measure of angle 1. The measure of angle 1 is equal to, and it says, half the sum of the measures of the arcs intercepted by the angle and its vertical angle. This is the angle, and isn't 3 the vertical angle? So the intercepted arcs to those two angles would be arc RU and arc ST. Those are the intercepted arcs of the angle in question, angle number 1, and its vertical angle. So to get the measure of angle 1, I would take 1/2 the sum of the measure of arc ST plus the measure of arc RU. I would add those arcs together and take half. So note that the angle's vertex is not at the center. It is not on the circle. Oh, is that exact thing on the back? Oh, look at that. How nice of me. I must have redrawn it. Much nicer picture, right? So look at angle 1. So angle 1's intercepted arc. I looked at that and for whatever reason it didn't look the same. So we've got is 1/2 the sum of the measure of arc ST plus the measure of arc RU. Then if we wanted to find the measure of angle 2, well, wouldn't the same thing be true for angle 3 over here? Wouldn't I have exactly the same formula because that's the vertical angle to angle 1? You can find either angle, either way. So kind of going back to what I was saying before, this is a different case where our vertex of that angle is not at the center and it's not on the circle. So this is a third type of angle. So to get the measure of angle 2's intercepted arcs are these two, right? So it would be 1/2 the measure of arc TU plus the measure of arc SR. And the same thing would be true for angle 4. All right, so look at example 2 directly below. If the measure of arc AB is 120. So I'm going to write 120 degrees here. Bless you. And the measure of arc BC is 30. And the measure of arc CD is 160. You were to find the measure of angle Q. This is going to be the long way, and then I'm going to give you a short way, because we're going to develop a new theorem for this. Isn't angle Q part of this triangle here? Right? And inside this triangle we have an inscribed, is this inscribed? Vertex at the circle. So this is an inscribed angle. It intercepts this arc here, 30. What do we know about angle A? It's 15 degrees. So just based upon that, I know that this is 15 degrees. If I can find the measure of angle C right here, then couldn't I add these two together and subtract them from 180? Well, in order to find the measure of angle C, it'd be a lot easier if I found this angle here, and then wouldn't I subtract it from 180 to get this angle here? So if I can find this arc, this missing arc right here, that'll be key. How do I find that missing arc? How do I do it? And do what with that? And then do what with that? Okay, so we're going to take 360 degrees and subtract from that the sum of 120 plus 30 plus 160. That gives me 280 plus 30 is what? 310. So how much is left over? So I get 50 degrees is equal to the measure of arc AB. So what's the measure of angle C? Doesn't, C is an inscribed angle. So it's half of 50, right? So it's 1/2 of 50 degrees, which is equal to 25 degrees. I guess I shouldn't say angle C, I should say angle ACD, right? Angle ACD, because there's two angle Cs. So now I can find the measure of angle ACQ. Aren't these a linear pair? So I'm going to take 180 degrees and subtract the 25 degrees, and what does that give me? What does it give me? 155. So this is 155 degrees. Now how do I find X? Angle Q. Angle Q is part of that triangle. How are you going to find it? You know this measures 15. You know this measures 155. How do you find the missing angle? Surely you can answer that question. Seth? Okay, so 180 minus 15 degrees plus 155. So this is 170 here, right? What's left over? 10 degrees. So angle Q turns out to be 10 degrees. Now, I want you to note that angle Q is a totally new type of angle. Angle Q is comprised of two secants intersecting outside the circle, rather than, like this one above here, two secants intersecting inside the circle. Look at this arc here, 50 degrees, and this arc here, 30. Doesn't this external angle, that's what we're going to call it, is an external angle, its vertex is outside the circle, doesn't it intercept this arc here and this arc here? What's 50 minus 30? 20, and then take half of that. What'd you get? 10. Wouldn't that have been easier? That's your new theorem. So flip it. So, Theorem 913 brings you to one more type of angle, which is an external angle, and I've drawn for you 3 different pictures down below. An external angle can be created from either 2 secants, like the previous example just had, or could it be created by a secant and a tangent, or 2 tangents? Alright, so what it says is if 2 secants, a secant and a tangent, or 2 tangents intersect in the exterior of a circle, so the exterior of a circle, then the measure of the angle formed is 1/2 the positive difference of the measures of their intercepted arcs. So you saw me subtracting the arcs this time, not adding them. So if the angle's inside the circle, you add the intercepted arcs and take half, but if the angle's outside the circle, you subtract the arcs and take half. And you will always subtract the smaller from the bigger. So for case 1, the 2 secants, to find this angle here, CAT, you're going to take this bigger arc, CT, so it's 1/2 the bigger arc of CT minus the smaller arc of RB. And then for case 2, we're finding this angle here, FDG, and we're going to take half of, what's the bigger arc? We're going to put an H here. Why? This is a major arc. So we're going to take the arc FHG and subtract from that the smaller arc of EG. And then interestingly enough, when you have 2 tangents forming this external angle, you're going to use the entire circle. Isn't one of the intercepted arcs from I through X all the way to J? And isn't the other arc from I to J? Aren't you using the whole circle? So you're going to take this whole arc here. We're going to take 1/2 of IXJ and subtract from that the measure from I to J. And the last thing I have for you is Alice playing golf. We just finished the Phoenix Open. What a perfect question. Alice is playing golf and her ball has landed behind a bush. This is the bush. Right there. If the measure of arc AB is 86 degrees, so I'm immediately going to put 86 degrees right here on that arc. And the measure of arc AC, so from A to C, they don't mean from here. It's hard to tell, but from A to C is 184. So from here to here to here. Arc ADC. Do you love what your book does? This is typical of something that your book would do. Find the measure of angle AGB. So they're referring to this external angle out here. And then what does this tell Alice about her next shot? So, the measure of angle AGB is equal to what? You have a tangent and a secant. What are you going to do? What's its intercepted arcs? Really, you can't answer that question. I find that hard to believe. What's the big arc that's intercepted? Here I'm looking at this angle and this angle. This is the big arc, isn't it? And that's the small arc. I can do all your work for you up here, but if you don't think for yourself and share as a class, then only one person is going to be doing the work for you. That would be me. And I'm not going home with you. So start participating. I've got 1/2 times the bigger arc is 184. The smaller arc is 86. 184 minus 86 is 98 degrees. And then half of 98 degrees is what? 49 degrees. So that tells us that this angle here is 49 degrees, but the question says, what does this tell Alice about her next shot? We don't need any more room there. If her ball's here, and she's obviously trying to get around the issue called the bush, what would that tell her? Why would she bother to figure out the angle measure? As if she really would while she's on the golf course. But let's say that she did. What does it tell her? See? Okay, so she needs to make a shot that's over 49 degrees to get over the bush. Now, I don't know how high the bush is, so you can't assume that she can go, over that way. So we're assuming she's doing a straight shot somewhere out further than the tangent. If she hit the tangent shot right here, that straight shot, what's going to happen? It's going to hit the bush and bounce off in some other direction, right? So she wants to hit larger or longer or wider than the 98 degrees or 49 degrees. So therefore, Alice wants to hit her ball greater than 49 degrees to avoid the bush. So that's it. Your homework assignment is page 46, 6 through 34. I want you to go grab a book now and get started on